Hello and welcome to the Design, Install, and Commission in Closed Loop webinar. Today we have Rich Shea from Victron, James Hall from Northern Arizona Wind and Sun, and John Cromer from Fortress Power. Whenever you're ready, Rich, take it away.
All right, thank you very much. The presentation here today is going to describe some closed loop options between the Fortress Power BMS and the Victron Energy product line. As a brief introduction, Victron Energy is it's a 50-year-old Dutch company that specializes in power electronics. So we basically, anytime you need to store energy from at one point for use in another, or to convert that energy from one form to another, we have some form of product that would facilitate that. One of the major ones being, in terms of the heart of the system, is our multi-plus and quattro inverter chargers, which are basically the beating heart of a system when it comes to directing energy either from the grid to loads or from the grid to batteries, from an AC coupled PV installation to the batteries, from the batteries to wherever you want the energy to go. So that's kind of where we come into this equation between the batteries, the BMS, and your use of the system. As a means of introduction, I'm going to share my screen here with just a few slides here that kind of describe where Victron falls in this equation. And I'll pass that off to my colleague James when I'm done with that. So starting here, basically this is representation of many types of systems that you could see out in the field, either AC coupled or DC coupled, or a combination of both. Under normal circumstances, you have this inverter charger that's sitting in the middle of the system that's either accepting power coming in from a generator or from the grid, or even accepting power coming in from a grid inverter on the output side. And what it's doing is it's taking this excess energy that you have that you're not actively using on the loads at the moment that that energy is being produced, and it's going to store that energy in a battery. At this point, I have a big question mark on top of the battery because who knows what battery you're going to use. The concept in general is that under these circumstances, the only way the quattro or the multi-plus inverted charger knows how to properly store that energy is by the parameters that you've programmed into it. It has no idea what it's connected to. It can't talk to the battery in general, and it's saying, all right, well, the user has to tell me how to perform this particular function and how do I charge these things properly. So what you've all probably done under normal circumstances is that you've gone in and you've consulted with your battery manufacturer, say like Fortress, and you've gotten the parameters for the charging, and you have to manually enter in the charge parameters into the inverter charger so that it treats the batteries in the way that the manufacturer wants. It gets the most out of the batteries. It also provides some safety because particularly with lithium batteries, you have to be careful about overcharge and over discharge. Preserve your investment as well as safety as well. So that's the traditional paradigm, which is you enter the information into your battery charger of your inverter charger, and then you rely on the fact that that information is correct and that information is going to treat the batteries properly. So one of the things that's come along with some of our software, particularly with our GX devices, which is the Servo GX or Color Control GX, is that we're now able to listen to battery manufacturers' BMSs directly using CAN bus communication. So basically what it's able to do is it's able to take commands directly from the BMS of the batteries, and that BMS is controlling the charge parameters of the inverter charger, and with our systems also from your solar charging when you're using the MPPTs on the DC coupled side of things. So instead of having commands that a user has to enter first and put into the inverter charger, this is taking commands directly from the BMS itself. It's a slightly different way of allowing the proper charge to happen to these batteries. So in any battery situation, we like to say that the BMS knows best about what should be happening with the batteries. They know what current should be going in at any one time. The BMS should know what voltages the cells should be seeing. They should know what the maximum discharge rate of the cells are at any one moment. So in order to facilitate this, we give over the control of the inverter charger, so not just charging, but also discharging to the control of the BMS itself. So in the end, what you get is a coordinated communication that allows the batteries to perform to their maximum potential, to last the longest, and also to have a smoothly running system that gets everything out of the system that you're hoping to achieve. We've done certainly been working with Fortress well for quite a while now, and they've done some great developments using our software in order to work with our inverter chargers and our Venus and operating system, which is included in the Servo GX and color control. So that's just sort of the basics, the basic layout of how a system works and why this closed loop system is so important, and how it can revolutionize, I guess, the way that these systems interact with each other to maximize performance. With that, I think I'll pass this on to my colleague James, who can go into a little bit more specifics about the programming of that itself.
Oh, I was going to say before you did, I like that picture in your presentation slide where you were showing off the Victron links, or the Victron power and bus bar system too. You know, I think that y'all thought through a lot of balance of system material components, as well as your inverter and charge controller product line. So we, commonly recommend that bus bar system as well. It just fits when you're doing outside a conduit battery combining.
Yeah, if I may, I'll share my screen again and go back to what you're referencing. Well, if I can find it, where it is.
There you
go. Yeah, so what he's referring to is just that as part of the inverter chargers that we have, we also have a line of modular DC bus bars, which can be put together in systems for attaching batteries to. We have ones that are fused options, which are called the links distributor. We also have ones that are just the regular bus bars with posts directly on the bus bars, which are called links power in. And between these two and the shunts, well, we wouldn't need a shunt with a Fortress battery because it's a closed loop system. But for other battery systems, for AGMs and 2-volt cells, things like that, there is a shunt option that fits neatly within that form factor. So it's a good way to neaten up a system, to make it very organized, and to be able to quickly see where there's any issues in the system due to on the DC wiring side.
And another thing, Rich, in the US market, I hear about Victron for off-grid, certainly, and RV markets, certainly, but that picture you had up, it certainly didn't look like a off-grid system. It looked pretty large, maybe a commercial 3-phase, which is like the exact opposite of tiny house off-grid.
Sure.
Victron has tremendous, commercial 3-phase experience in other countries, does it not?
Yeah, certainly. Sort of due to the nature of our inverter charger technology, we can stack these systems in many different forms. Not only do we have sort of scalable individual units from 250 watts up to 15 kW watts as an individual inverter charger, you can parallel those well, up to 6 units per phase and up to 3 phases. So we do have some quite large industrial 3-phase systems out there, around 180 kW. For US 120 volt units that we have available, we can go upwards of 150 kW. When it comes to grid connected things, one of the things that we're adding on more and more is the UL certifications for direct grid interactivity. So right now we have several models which are UL 1741 certified. You can see those on our website. But we're increasingly getting ones, expanding that to 1741 SA, particularly for the Multi+2 product line, and the Multi+2 product line, which is the newer version of the inverter chargers that we have, will be the ones that will allow grid interactivity, not just at the residential level, but also at the industrial level. And we're expecting that certification to be done. Certification itself should be done sometime fairly soon. Products that have the certification, at last update, I'm thinking somewhere by the end of the year. So that's going to be a 48-3000 model to start with, and then we'll have larger models to go after that. Again, stackable, parallelable per phase. So you can, even with that initial 3,000 watt inverter charger, you can still make systems larger than that based on that building block.
Well, is that 3,000 watt charger, is that 120 volt or 120 240?
That individual one will be 120 volt.
Yeah. So that's real interesting to me, because that'll be, not only does Victron being able to manage large three-phase have some of the largest three-phase opportunities that combine with Fortress. Our batteries go up to 370 kilowatt hours. 150 or 180 kW is about as large of an inverter system we'd want you to pair with the eVault Max and three-phase. So that's kind of a nice fit for maximum system sizing and battery sizing. But also with a 3 kW, you could get into your smallest minimum three-phase project sizing, which is sometimes we see homes on three-phase that might just have very small three-phase loads, and being able to provide a true three-phase signal in a smaller form factor is a real pain point. So I really like how diverse your product line is, and how well it fits into a 48 volt system platform. So thanks for sharing that with us.
Yeah, my pleasure. And the functionality and the sizing of all the stuff does come from input from the industry, from people like James and people like yourself. We want to make the products that fit the applications that are prevalent in the area. So, feedback is always welcome as to which models we're looking for. So thanks for commenting on that.
Yeah, I'll share some of these here shortly, and kind of discuss a little bit more about the practice as use with respect to the inverter equipment and the battery systems, and what we like as a engineering company and a distributor with respect to the Fortress products and the Victron equipment.
This is James Hall with Northern Arizona Wind and Sun. So take it away, James. You're the presenter now.
Can you see my screen?
Yep.
Perfect. Now let's see here. Can I move this out of my way?
Yeah, they don't see that on the screen. They just see your presentation.
Perfect. Well, to introduce myself, I'm James Hall. I'm the sales manager and lead application engineer here at NAWS. And I'm very pleased to have you all joining us here today. I'm going to quickly talk about who we are, why we're here, and what we can do for you. So let's see here. NAWS is a solar electric and battery systems distributor located in Flagstaff, Arizona. For over 40 years, our team of engineers have designed and supported residential and commercial systems across the United States and around the world. We are a retail e-commerce store and offer retail and wholesale distribution. And we like to believe that we are one of Victron and Fortress's best distribution partners. So I guess the question is, why are we here today? And so we're going to take credit for assisting in building the relationship between Fortress and Victron. So as an influential distributor, we tend to work with popular manufacturers that we offering input and recommendations to help improve their products and overall functionality. Obviously, this is a mutual and beneficial solution for us, as if we can influence, then we can use them for a wider range of solutions. So this is kind of what happened here. To improve the functionality of Fortress batteries, we recommended that Fortress close the loop with Victron, and we saw to it that they had the correct contacts to do so. So our engineering team here at NAWS specializes in a diverse range of system applications. We design solutions for projects all around the world. Everything from basic grid tie systems to major microgrid systems. So for residential applications, obviously, we do a ton of grid tie, ESS, grid backup, And we really specialize significantly in off-grid applications. We do quite a few tiny home solutions. And yeah, again, general battery backup for residential. For commercial applications, we do single and three-phase grid tie. We do peak shaving and backup systems, standalone oil and gas, telecoms, cathodic protection systems, very large systems like microgrid, and even very small commercial systems like mobile offices. And we even dabble in the mobile industry, doing RV system designs, marine system designs, even commercial marine system designs, mobile generators, and solar generators essentially, and mobile security and monitoring systems for mines or job sites and stuff like that. So I can pretty much guarantee that our team has engineered a solution for just about any application. Well, any application that could include solar and or battery power. So I guess really, like, why does our team appreciate or like Victron and Fortress? Well, you see, Victron's low frequency switching inverters are vastly configurable, as we had just talked about. They're low frequency switching, grid forming inverters capable of doing single phase, split phase, three phase. There's really no other inverter system as capable and configurable as Victron inverters are, okay? Plus, for DC coupled applications, their charge controllers offer a very wide voltage input up to 450 volts and massive power output up to 200 amps. You can pretty much do a DC coupled system with, for the most part, well, let's just say very limited constraint. What I mean by that is, I mean, you can put Rich, what's the limit on like the 200 amp charge controllers? Something like 20 of them in a system?
Yeah, it does approach that number, correct? Yeah.
Yeah, so it's just a ridiculous amount of current that can be delivered to a system in a DC coupled form factor. So there's literally a charge controller for nearly any application. Plus, their control systems offer real-time system monitoring, and their platform is open source. So it's very configurable for specialized applications, and a nerd like me can really appreciate that. We here have done some very unique things with Victron equipment, and that's why our team really appreciate their equipment and the diverse versatility that their equipment offers. Now, Fortress offers an exceptional lineup of battery solutions. Their batteries are lithium iron phosphate, so they're obviously incredibly stable. They have an internal BMS, and they have pretty much all of the appropriate NRTL listings to do pretty much any installation. The eFlex battery is an indoor-outdoor rated battery solution up to about, 80 kilowatt hours, right, John?
Right. Yeah, it's recently increased from 81 to 86.4. So it used to be up to 15.
You can add a couple more batteries.
Now we can do 16, since our cabinet can hold 4. So.
Oh, okay, I see. Okay. Yeah, so we're most often using the eFlex for applications in the 10 to 30 kilowatt hour range, but obviously the flexibility allows us to increase the system size and whatnot. For larger systems, the eVault Max, it's a beast. It's a fantastic solution for our larger residential and commercial applications. We often use these for applications where the desired battery storage is slightly above 40 kilowatt hours to start. One of the things that I personally really like, although it's not very common, is the fact that Fortress batteries are to some degree field serviceable. This is incredibly important and hugely beneficial to clients that are in remote locations with minor issues. Again, it's not very common, but a lot of manufacturers in the lithium battery industry lock their batteries down and don't let anybody fix them. So this is a very important consideration from our perspective. So I'd like to share a large system, kind of like what we were talking about mid-transition. This is a fairly large, completely off-grid residential system located in Mexico. I suppose it could be considered to some degree along the lines of a commercial system as well. The system has about 85 kilowatts of solar power. 50 kilowatts of that is DC coupled. 35 kilowatts is AC coupled. The system is a three-phase 120 208 volt configuration with a 60 kilowatt inverter system, and it includes about 200 kilowatt hours of lithium battery storage. The system can be remotely monitored real time anywhere in the world because of the Victron VRM, and the system was completely commissioned remotely from the comfort of my office, partly because of COVID, and this system was essentially commissioned during COVID. And yeah, so the ability for Victron to be commissioned and configured remotely is hugely advantageous for our team when we're designing systems, because essentially we can assist in that commissioning process without needing to leave the comfort of our office. So I think I might be able to share this system live. Can you guys see the VRM?
Yes.
Perfect. So essentially, this is a real-time perspective of the system. It's live. We can see it's averaging over 300 kilowatt hours a day. It's possible for us to monitor. Let's see if this is going to participate with me here. Oh, I just realized the internet is constrained. Well, regardless, as you can see, this is just an overview of the system performance. And basically, we can see every parameter in the system, and this helps us troubleshoot. It helps us, oh, there we go. It helps us identify system problems and or monitor and evaluate things like inverter power. Well, this is AC loads and inverter power and curtailing and PV production and much more, all through the Victron system. The ability to do this is, again, very important when we have very large systems. And this is, again, one of the reasons why our team really appreciates the Victron equipment. So I just want to quickly touch on how easy it is to set up the closed loop communications between Victron and Fortress. And then I'm going to hand this off to John. So as John will probably go into more detail about, the basic principles of closed loop are kind of as follows, right? So you need to configure the battery to communicate properly. Basically, the battery and the GX device are communicating using CAN bus communications. Knowing what that is not really that important, but imagine it's a language, and the batteries need to speak the correct language that the Victron the Victron GX device is interpreting. So just setting the communication protocol correctly on the battery side, configuring the servo to receive that communication properly, and then literally plugging the two communication into one another is really as simple as it is. As you heard from Rich, basically, this allows the batteries to provide accurate information, allows the system to optimize charging and discharging limits. And this is hugely advantageous to us because, again, we're often assisting in the commissioning process remotely. And this gives us the assurance that both the batteries and the control systems are able to relay accurate information, accurate state of charge, gen start parameters, charging parameters, and everything are accurate with respect to the battery and the inverter system. And this is hugely advantageous to the end user as well, because they're able to see this accurate information. I mean, don't get me wrong, a shunt-based battery monitor, when configured correctly, can be fairly accurate, but any misconfiguration or miscalibration can cause misleading information. And when the BMS is communicating to the GX device, it's all linked, basically. So it's all very accurate. So yeah, I mean, again, the battery systems are locked in sync, kind of like the boy band, together as one, right? So, all right, well, I think I'm going to hand this over to John to kind of elaborate more on the Fortress products and to provide more detail about the closed loop. But I want to thank everyone for joining, and I want to let everyone know that if you need any assistance from our engineering team to design a system, or even information about the communications and what's needed and batteries and so on and so forth, that our team is happy to assist in helping with designing these systems and get you the equipment that you need.
All right, and I think you know, one feature we haven't yet touched on with the Victron product line that I think is unique to Victron, and so I think it's worthy of mentioning, is that you can energize the Victron equipment from any end of the power chain, whether it's solar or grid or generator, and you know, that can be very useful in the specific case of a deep discharge battery, where you know, other inverter manufacturers or charge controller manufacturers have, you know, minimum voltages that they need to see from the battery before being able to turn on and charge the battery. Whereas if you have solar power going into a Victron charge controller, for example, you can use it as you would a trickle charger for extreme deep discharge cases, which can be all the difference between, you know, having to go out and buy a trickle charger to and you know to perform that, you know, low voltage deep discharge recovery. You know, with a Victron, you can even, you know, schedule that remotely and enable it and log it in charge. So that's pretty unique to the industry. I haven't come across another charge controller that has such a robust deep discharge recovery feature.
Yeah, it's not just the charge controllers either. The inverters receive AC input and they will power up the DC bus. DC to DC chargers sort of do the same thing. You configure them as essentially a DC, like constant voltage, constant current power supply. Pretty much every piece of equipment in Victron's lineup allows you to power up the DC bus independent of batteries, which, like you said, is very important when it comes to a graveyard situation. Someone's just really pushed their batteries well beyond the limits that they should have, and the system has shut down.
Yeah. Okay, so we're going to get back into the Victron discussion in just a minute, but I do want to give a very quick product overview. If you take our other webinars, you'll get a more robust product overview. This is the quick version. You know, Fortress and its residential product line that scales into commercial. You know, we do have a commercial product line for 480 volt three-phase that just starts squarely within commercial. We're not going to talk about that today. You know, but our residential product lines, you have the eVault Max and the eFlex, and I think James described the use cases correctly in that the eFlex batteries tend to be 30 kilowatt hours and down, although they can go higher. And the eVault, you know, it starts at 18.5, but it's very common to see two of them and just to start at 37 kilowatt hours, you know, on up. So a little bit more scalable into large battery system sizes with the eVault Max, scalable all the way into the commercial product range. The eFlex is kind of the battery for when the eVault Max does not quite work. It is our rugged battery line. We'll talk more about that later. But the eVault Max, it's easy to install. It comes on a wheeled base, so in your garage installations, it can be as easy as uncrating the battery, wheeling it into place, and then one set of battery conductors to the bus bar for 18.5 kilowatt hours. It has removable cell packs so that if you have to get it up and down the stairs, you can disassemble it and reassemble it with relative ease. It's not a feature that we advertise in our print literature, but we do discuss it in our training webinars. So, very popular. What I like about the eVault Max is that it's a second design iteration of the original eVault. And so serviceable items like the fuse or the BMS or the bus bars in that deep discharge situation we were previously discussing, all of that is front accessible. So you just take the front panel off, you can access the BMS, the fuse, and the bus bars. Not that you should ever have to, but if you're an installer who installs, hundreds of job sites a year, fleet management becomes an issue. The ability to get on and off a job site during a service call is an issue. And we have all those design considerations go into the design of our product, the eVault Max being kind of the most installer friendly large battery on the market, at least in my opinion. And of course, I'm biased because I work for Fortress, but I chose to work here because I like their battery design. So this is a 20 eVault Max installation we've had in operation now since I don't know, I guess since when the product first came out in November of last year. And we have a number of them in the field. The eFlex is our rugged battery. It has a 1 C rate or 5 kW per 5.4 kilowatt hours output capacity. It is a sealed battery. And this is important because you can get like IP55 batteries like the eVault, and some might say that they're outdoor batteries. And we say, no, keep them inside, because they're not actually sealed against dust and humidity. And if that dust and humidity gets inside the battery, that can result in degradation. And so if you're in an outdoor setting, even if that's inside a battery cabinet or a storage container, the eFlex battery has some features that make it a more rugged outdoor battery that's more than meets the eye. So like the eFlex has a very thick aluminum case, about a 1/4 inch thick, that wraps away all around it. You're not going to find another battery on the market with that thick of an aluminum case. What that allows for is even heat distribution across all of the cells, not allowing that heat to get concentrated in just like the front plate of the battery in an outdoor location. And certainly NFPA 855 is trying to force the batteries outdoors. And so if you're near the ocean, if you're in a dusty environment, if you're outdoors, or if you just want to do a wall mount, the eFlex battery fits the bill for that. The ones that are leaving the factory gate this month, so will start showing up on shelves in about 6 weeks or so, now include the wall mount bracket as well as an updated gasket lid. So the lid is no longer glued on but pressed on. It's a little bit easier to remove if you have to service the eFlex. One other thing that's nice about the eFlex is there's no master battery. So you just plug in all the communication cables and turn it on. That's a little bit more simple of a setup than your standard kind of 5 kilowatt hour battery. So this is my favorite layout for the eFlex. You put it on the wall. You position the terminals in such a manner that you just go straight up into the trough via cord grips. You put a bus bar into that trough and then go straight up into the 48 volt inverter. So as long as you have a hydraulic punch and some bus bars and an 8-inch trough, you can have a very neat and clean looking installation with good cable management all on the wall. We do have a brand new cabinet for the eFlex, and it's kind of a unique cabinet in that you could just buy the lower unit called the DuraRack, and that's a NEMA 3R battery cabinet with an included DIN rail that is particularly useful for adding a heating element or thermostat into that battery box. So, and it, lithium batteries can get down to freezing temperatures, but just because you can, and that's the maximum range of the battery, doesn't mean you should. I mean, any environment, whether it's, in Kansas City, Kansas, and you're putting the batteries in an unconditioned garage, and in the wintertime, that garage is going to get down into the mid 30s or 40s, or more extreme circumstances like, true cold weather environments, an outdoor location, you'd have a little bit larger of a heating element. But, Stego makes Snap-on DIN rail, heating elements with thermostats built into them. You just click it into the battery cabinet and away you go. So you have a nice outdoor rated NEMA 3R battery cabinet, and you still don't have to worry about things like humidity and dust getting into the ventilation of the cabinet, because the battery inside is nice and sealed and has really good thermal management of distributing that heat evenly across the cells of the battery. The Flex Tower is the Durarack plus an upper cabinet that can mount up to a 15 kilowatt inverter. So I've checked with Victron. You cannot fit 2 Victron 10 kW Quattros into this cabinet, but you can fit one. And what that does is it allows for easier wiring between the E-flexes. You can just shove it includes battery cables with a power distribution block, but then as far as the wire run between the power distribution block and the inverter, you can just put it up into the cabinet. Now the cabinet does come with internal fans, and so the heat generated by the inverter itself is forced blown out of the cabinet with dust filters and things like that. Also a rapid shutdown budget and conduit entry points for generators, solar, as well as parallel stacking of the cabinets so that they can go side by side from each other. I'm not going to go into the details of Fortress design, but we do use prismatic batteries. I mean, we look at, quality selection, materials, and design principles and try to incorporate them into all of our products. When we talk about closed loop communication between our batteries and Victron, that communication is driven by cell level information. And prismatic cells having a little bit larger of a native cell than cylindrical cells allows us to put a voltage monitor on every single cell in the battery. Now, in the case on the right, this was a cylindrical cell battery that was not outdoor rated, left outdoors in the coast of Puerto Rico, subject to torrential rainwaters for like a year. And then it was not surprising that the battery did not turn on. But the thing is, if this was not such an extreme circumstance, but this was just degradation of the battery internally over a 10-year life, if you're not monitoring every single cell in the battery bank, how do you know that you're going to face a warranty issue, at year 8 or 9 when there's so many cells in the battery? You don't. So that, that issue that would trigger a warranty at year 8 or 9 doesn't get discovered till, year 12 or 13. And by that point, you're out of luck. With prismatic cells, slightly larger cells, you can monitor all the cells and, actually confirm that you're getting the value you paid for. Fortress, we have a lot of online resources. We have a support ticketing system. I'm not going to get into that system today, other than to say that if you log in to the support center, you also get additional features like the ability to book a meeting in advance with our technical support team. So if it's your first time through a system, you want to commission it properly, log in, book a meeting, we'll help you through it. We have a nice chat widget you can use to text message with our team. And then we also have an accessories section where we list, say, bus bar recommendations based on how many batteries you have and how many inverters you have. Whether it's that, if you say, hey, you're just talking about thermostat heaters, what do you recommend? We have a accessory section for heating where we make DIN rail heater recommendations, external trickle chargers as well. Oh, good to know. We're about to talk about our inverter guides, and that's relevant to Victron. On our website, you'll also find product manuals, And to some extent, our product manuals were kind of inspired by Victron, because we noticed Victron was doing some really smart things with their product documentation, such as not just having PDF manuals, but also having HTML5 manuals that display a little bit better and are more user-friendly on the cell phone. So we've done the same thing with our manuals. We've digitally converted them to accessible HTML5 files, making them more cell phone friendly. Our product manuals contain everything but the kitchen sink. So, everything you need to know about the specific product itself is in the product manual. But what we found is most installers don't want to read, a 100-page manual just to install the dang thing. They want to get on and off the job site as quick as they can. So what we want the installers in the audience to know is we have inverter guides on our website, and we have an inverter guide that is written specifically for Victron, but it's not just about how to program the Victron inverter. It's more of the start to finish commissioning read through. So it goes through the battery setup process as well as the inverter setup process. And so when you're sending your installers out to the field, as long as they have that inverter guide, they should be able to successfully commission the system without interaction with our support team, although we're there if you need it. So what does that inverter guide look like? Well, some of the screenshots we saw presented a little bit earlier, show up in our inverter guide that basically say, hey, this is what it looks like when you're setting up the inverter. Put in these values at these locations. This is how you enable the battery monitor on the Victron system. So the field manuals or the inverter guides involve, powering up the system for the first time, programming the inverter settings, and also some basic service information, of which more details could be found within the product manual of the individual battery. And so our inverter guides, they contain instructions for both the eFlex and the eVault Max. The eVault Max requires you to program an inverter protocol ID, and of which Victron is number 4 on the protocol ID. So that's if you will need to know that information. So the problem with our batteries is they're simple enough to set up in the field and power on without looking at the manual. But if you don't look at the manual, there's going to be a couple of gotchas like this protocol ID, or the fact that after you program all the eVault Max LCD screens, you need to power cycle the master battery, that you won't catch if you don't read this inverter guide or product manual, if you would rather read a much longer document. I think one of the most important things to know about the Victron communication is that the communication that we use coming out the eFlex or the eVault Max is not just one communication circuit. We have a communication circuit for the batteries. We have a separate communication circuit for one type of inverter that uses Modbus communication. We have a different communication circuit for CAN bus communication for other kinds of inverters. And the pins on the communication output don't always meet up with the pins that the inverter needs. Now, on some inverters, getting this communication correctly is very important so that you don't short out the communication board. Other inverters are more robust, but you can find the map of that for Victron. And basically, whether you're crimping a custom cable, which is normally appropriate anyway because of the cable length between the two inverters, but it might surprise beginners if they're unfamiliar with that, or just using an Ethernet keystone to make the conversion. And that's a little bit less, skillful than what it takes to crimp an Ethernet connector if you've never done it before. So whether or not you're a beginner and you use the Ethernet keystone, or you're making up your own communication cable, you do need to be prepared to make that crossover from, in this case, this is for the eFlex, and we connect pins 4, 5, and 6 to the eFlex, to pins 7, 8, and 6 on the Victron inverter, regardless of whether or not it's a type A or B format Ethernet connector. And then last but not least, all those picture settings that you saw on the Victron on how to, enable the communication on the Solarc end, in our inverter guide, you will find start to finish steps so that you can just use one guide and install and commission the system quickly. Another resource to find on our website is minimum inverter sizing guidelines. What's the fewest amount of batteries you can pair with the inverter that you're selecting? We'll have more on that in a minute. And that minute is now. So we have on our website a training portal where we put a number of classes. These are the classes that we use internally at Fortress when we have new hires to train them up on basic solar and battery design principles, in addition to our product line. So you'll find classes that are purely continuing education classes that are, NABCEP registered, and then you'll also find classes that are more specific on our specific products. So I'm going to mention a couple of classes that are useful to the Victron audience. The first would be, so we have a wide variety of classes. Just go to our website, click on education and training, and you'll get there. But like on how to avoid battery undersizing. So on our battery 101 class, we get into, hey, just look at the data sheet on the battery. The data sheet will have a kilowatt output rating, and the inverter has a kilowatt output rating, and make sure that the battery kilowatt output rating is greater than or equal to the inverter kilowatt output rating. Because if it's not, you're not only are you buying inverter capacity that you're not going to use, but you could get into other, more lesser known design issues involving the inrush capability of the inverter compared to the battery. There is such a thing as putting too large an inverter on too small of a battery, and it's not just having to do with the continuous output of the batteries themselves. So back in the day, you had to worry about this with amp hour capacity, but because lithium performance is so robust at fast discharge rates, we can just talk about it in terms of kilowatts. Another class we have is the Battery 250 class, which is a great class on off-grid modeling. So, we have a tool that's based off PV watts and 12-month electric bill history. So this is for off-grid modeling, but it's also for grid-tied homes that maybe don't have quite the capacity to run completely off-grid, coming up with a useful and meaningful metric of how off-grid are you. And that can be useful for convincing the customer, hey, maybe you don't want just, 10 kilowatt hours worth of batteries. This is what 20 kilowatt hours can do for you. Type of sales discussions, breaking that out into quantifiable user experience in ways that you won't get from other manufacturers, quite frankly. So in this Battery 250 class, we take PV watts production, we take your 12-month electric bill history and run it through a simulator that does load profile modeling and battery bank capacity size estimates combined with your solar production to answer questions like how many days a year is the grid charge or the generator charge expected to run. So if I can sell you a battery bank that'll run the home off the grid 365 days a year, like a 10 kilowatt hour battery, but if I can show that a 37 kilowatt hour battery takes the home off grid for 250 days out of the year, that might get the end user to say, you know what, I thought I only had budget for this, but if I spend $20,000 more, I almost have a off-grid home. So here's the project budget. Give me the larger battery bank size. Also could model things like if you're in a zero export zone, what your outflow to the grid would be and how much of that energy is captured because you go with a larger battery bank size. So that's a pretty interesting class. Last topic, firmware updates. you installers should be prepared to do a firmware update on every site they visit. The eFlex and the eVault Max ship with firmware on them to communicate with Victron, but you never know when we have an updated feature. Like if with Victron, we're already on CAN bus, but there is an inverter manufacturer out there we're converting from Modbus over to CAN bus on, and so for that functionality, you need the firmware update tool. The firmware update tool is also just useful for system commissioning to tell you that all the batteries are on and functional. And so if you use the firmware update tool for system commissioning, even if you're not updating the firmware, it can speed up your commissioning process. So, what is this firmware update tool? Well, it's a tool we provide to our installers. It's really not a useful tool for our end users. We'd rather our end users not worry about it and wait, a month or two for our Guardian Hub, monitoring hub, which will do firmware updates that way. So stay tuned for a webinar on that. But with our firmware update tool, if you're a Fortress installer and you don't have this yet, just go ahead and go on to our support page at support.fortresspower.com and request a firmware update tool, and we will stick one in the mail and send it to you. And basically, by communicating with each battery, rather than going around and confirming that all the batteries have amperage flowing in and out of them on the individual screens, you can just see it in a central interface. Obviously, there's more you can do this. You can play around with the contactors. If you're an installer, you can override the safety feature of the battery. If you're trying to unlock the contactor at a deep discharge event to recharge the battery, there's some advanced features you can do it with, but we want our installers to have this, so fill out a firmware update tool. That way, if you're going to site on an older system and you want to get it to communicate with Victron, you're not going to have something like the firmware version of the battery trip you up. With that, that's the kind of the end of the presentation part of the program. We have till the top of the hour to go through questions. I'm going to rattle off a few real quick, and then feel free to chime in, James or Rich. But we have a couple of questions. Drew says, why does the battery control system, it strikes me the loads have higher priority. If the job is the system is to satisfy the loads and not optimize battery life, the limits are hard when they should be hard. Well, Drew, you can always just keep the battery running in voltage-based control and not have the battery to inverter communication. So, if you want to run the batteries harder, you can. But most customers, when they buy a 10-year warranty battery, they're really concerned about not having to replace the batteries at year 10, but trying to eke every kilowatt hour out of it. And in some cases, yeah, go ahead, James.
Also, voltage base, when it comes to lithium, and you can elaborate a little bit more on this, but when it comes to lithium, voltage-based configurations are just very inaccurate. The upper and lower limits of lithium are relatively narrow compared to what common inverter systems were originally designed for with respect to lead acid. And so voltage-based limits, charging and discharging are really not ideal for modern systems, especially when you can relay state of charge and do hard shutoffs and or grid transfer at a specific state of charge. Like if you want to run your battery down to 10% remaining capacity, just set the grid transfer or the auto gen start to 10% SOC, and the system will just transfer rather than configuring it to 20%. Right, John?
Yeah. There's a lot of additional performance you gain out of the battery when you're doing the closed loop, and that might be that it's not so much when you talk about degradation of the battery at higher rates of discharge, like 1C rates instead of C/2 rates, or 1 hour discharge rates over 2 hour discharge rates. Lithium, no matter whose battery it is, really wants a 2 hour discharge rate, for maximum product life. And there's no need when the battery is down at below a 10% stated charge to have a 1 hour discharge rate. And there's no need when the battery is up at the very top of its state of charge to have a 1 hour charge rate. And so having BMS control allows you to be a lot more precise in your charging and discharging so that you can charge faster and discharge better than without it. So, I personally would always do closed loop communication, but if you want the inverter specs to be governing the battery, you can do voltage based control. We have found not too many inverters actually allow you to program all the settings and voltage mode that you would want to for lithium, and whereas programming and percentage is more user friendly.
Also, the inverter voltage is not the same as the internal voltage of the battery. There's usually quite a significant discrepancy between the perceived voltage of the system and the actual internal voltage of the battery. In a closed loop configuration, the batteries are relaying internal voltage at, the voltage at the inverters has to go, from the cabling on the inverters, disconnects through the terminals in the battery, through the contacts in the battery, through the fusing in the battery. By the time you add that up, there's losses, and you're never, especially under high load, you're never going to have an accurate voltage. It's just not a really good way of doing things, open loop, if you can avoid it.
What we have seen, not with Victron, but with another 48 volt inverter that has a quality reputation and has been on the market for decades, that if you're in the minimum battery bank sizing, or you have actually bought fewer batteries than what the minimum battery bank sizing of the inverters recommended, that being able to stop at the end of the charge cycle can throw over voltage error when the battery disconnects and stops charging on the inverter itself. And when we enable closed loop with that particular well-known battery inverter model, you don't have the problems at all. So, it's like having better brake pads for your battery at the start and stop of the charge and discharge cycle. Because you have better brake pads, you have a higher performance vehicle. You can drive that battery faster without necessarily degrading the life of the battery. Okay, another question. This is Fortress, 18.5 kilowatt hours to zero discharge is the rated discharge rate. It says the warranty requires greater than 10 or 20% for regular cycling. So the way our warranty goes is if you drive the battery down to 0%, we do not void your warranty. However, if you drive your battery down to 0% every single day, not only will you have warranty issues, but you will also have performance issues. No battery works well at 0%. So, under daily cycling, we want you to go down to 20%. If the power fails and you're sitting at 20% overnight because you're waiting for that solar recharge and you got the tax credit, you can only charge by solar, we don't restrict access to you using that 20% remainder for backup purposes. But for demand management or daily cycling, we want you to go between 100% down to 20%. And quite frankly, that's in the best interest of the client too, because that's what gets them, thousands of more cycles out of their batteries. It's kind of the limit of lithium iron phosphate. And so, simply a battery that goes from 100% down to 0% every single day, will not last a 10-year span.
This is very common in with most reputable battery manufacturers, not just Fortress, but most other lithium battery manufacturers. This is very common practice.
the point of a warranty is not to have to use it rather than to use it. If you're a solar installer and you have to do a warranty replacement of every single solar array you install, you're going to go out of business, and someone else will do that warranty work. So, it's the same thing with batteries. If you're too aggressive by what is on the data sheet, going from 100% to zero every day, that is not going to be as good of a user experience.
I think this also goes to the importance of a properly specified system. If you're constantly draining the batteries every day, the question is, what parameters were put into the equation when you built the system? You obviously wouldn't want to design a system that did that. So having the services of, like what Northern Arizona Wind and Sun can provide, and with the resources that Fortress Battery provides on their website, it'll help you size the system properly so you're not constantly pushing those limits. And that makes the whole system work more smoothly, which is the end result that you want to have.
Yeah, Rich, I'm going to stick around for some of the Fortress related questions, but why don't we prioritize some of the Victron related questions to start out with? That way the Victron guys who are here can take their leave.
Sure.
So can the Fortress or Victron system provide state of charge to span IO load shed? I know we don't have that capability yet. Not that it's not possible, but we haven't developed it internally. Do you have any smart panel integration at this time?
I didn't hear the middle part of that question. What was it to do what
The
with?
SPAN IO load shed. So the SPAN smart panel, or Lumen is a competitor. Do we have any, direct communication to those smart panel systems?
I'm not aware of any that we're working on at the moment, but that's certainly something that I can double check with our software engineers.
Okay. And the Victron, is it pursuing UL certification for the Smart Solar MPPT line of solar chargers? Or what is the strategy for Victron when it comes to its UL certification of its inverter for solar charging?
Well, the Smart Solar MPPTs are all UL certified. What I was referring to was UL 1741 SA for the actual grid interactive type of system. But right now we have, the multi-plus 3,000 watt units and 2,000 watt units are all UL 1741 certified, as well as the Blue Solar and Smart Solar MPPTs. The goal is to roll out more and more of these models over the course of the next weeks and months and years that will be 1741 SA certified. So right now, in terms of backup power in residential applications, RV use, off-grid use, the 1741 sort of meets that criteria. But once you talk about getting into the grid, moving energy back and forth, you run into a whole other level of requirements under the SA, add on to the 1741. So that's the part that that's the part that I was referring to in the beginning. That level of grid interactivity to follow all those particular rules is coming up.
All right. Let's see. I think that is the extent of the Victron related questions and answers. So I'm just gonna go back up to the list of questions that are not answered yet and get going on them. So just give me 1 second, unless there's any that you see, James, that you'd like to chime in on. So
Not sure I know where to look. Just can see your chat.
check the GoToWebinar questions toolbar. It's a drop-down menu, and you'll see some of them go down. I'll take it away from this.
I do see one referencing the Victron DC to DC converters.
Go for that.
It's asking, I think the gist of the question is, right now we have some DC to DC converters used for battery charging, which are limited to 30 amps right now. But yes, there will be a larger model coming up well, again, coming up sometime within the next year, which will have more amperage than the single unit 30 amp. I believe that the target value is 60 amps for individual unit.
Yeah. Drew, the consumption of the heaters are around 50 to 100 watts. They turn on when the battery cabinet is at 40 and turn off at 50. You know, the how much energy that heater uses is purely dependent upon the ambient temperature and how large of a space that you're heating. Now the Durarack is not a large battery cabinet, and so it's a new product. We haven't done any actual field testing of the thermostat in cold weather environments yet. But the point is, your lithium battery chemistry, as a chemistry, although it can go down to freezing, and this is true of all batteries, they can tolerate cold temperatures, but charging and discharging at cold temperatures is harder on the cells. And so, as far as what is ideal for the battery, it's to put them in a battery box or a heated cabinet, which is one reason why you don't put lead acid batteries outside, even when you're using lead acid. So the heat that it takes to warm the batteries, if it's step one is to put them in a battery box, and then step two is to put them in an insulated box.
I mean, see, a lot of people get tied up on this. We deal with this on a daily basis. I think it's really important to clarify that the batteries aren't going to be damaged because they're used in a cold environment. The BMS is going to self-protect. The inconvenience that you have is you won't be able to charge the batteries because the system's going to limit charging because the temperature is too cold, and then you have to find a solution to warm them up. And the reality is how important this consideration is really is depending on your geographic location, right? So, there are obviously lots of clients who have this grave concern, and the Stego heaters are one solution, but they're just an enclosure heater. You can find all sorts of different enclosure heaters on the market, and I'm not sure what the capabilities of your Guardian are, but let's hope maybe there's some relays on there that are configurable or something to potentially offer control, more refined control for heating, and specifically for only heating when solar power is available, when an excess of solar power is available and you need to essentially charge.
You can use any relay driven control built into the inverter. That is an advantage of using an AC heater instead of a DC heater, is that you can still use the low battery cutoff programmable setting of the inverter to prevent the heater from draining down the battery. So
well, even Victron charge controllers have the ability to, they have relays on them that are configurable based on outputs, and the servo has relays that you can configure. You can even dabble in some very customized configuration to control those relays, or external relays and whatnot. So there's ways to set all this stuff up depending on how complicated you want to get it.
Yeah. All right. So, Matt, I don't think that code driving the batteries outside, and when I talk about that, I'm really talking about NFPA 9540 drywall requirements, forcing the batteries outside, and maybe in the future there'll be minimum size room requirements for the batteries as well. But there's certainly jurisdictions that want the batteries to be in an outdoor setting, regardless of the impact on the battery. I don't think that's going to drive a resurgence in the lead acid. You just get into things like the weight and the difficulty when you're talking about, whole house backup systems. When you get in, if you're doing lead acid, you need to install multiple days worth of storage for it to be an effective home backup system, and just getting those batteries on and off site is a heavy burden to bear. And let's see, other questions. These are newer questions. Victron, thanks. 100 watts is not good. Well, Drew, that's why we have different batteries and battery bank sizes. If you don't, and again, it's not running the heater 24/7. It's location dependent, which is, you can pay an engineer to do a heat analysis on your battery box and location to know precisely how much energy it'll take. David, Fortress battery sizing available on the website. You need an installer to use it. No, you don't need to be an installer to use it. You just go to our website, go to our training portal, sign up for the battery 250 class, and we share our spreadsheet with you in addition to having a 1-hour class on how the spreadsheet was built so you can understand to use it. So David, is the cabinet insulated at all? It's just a painted metal cabinet. I mean, it's designed to go in an outdoor environment. You are welcome to add additional insulation to it. So that will just be on a case-by-case basis. There is definitely room to add insulation on all sides except the side where the DIN rail bus bar is located. On the side where the DIN rail bus bar is located, if you wanted to customize the battery cabinet, you would probably have to get like a type X drywall cutout or a foam cutout because your traditional padding would not fit. You'd want to keep that at least a good half an inch away from the power distribution block and DIN rail. But the DIN rail is off the wall by over an inch, maybe an inch and a half. So while there is some insulation for it, you could also try some other solutions to insulate. Like in the winter time, there's nice ways to do insulation, and then there's Mississippi Bubba ways to do insulation, like putting a blanket over the battery box. So that's going to be case dependent as well. Battery technology is better, flooded or dry cell batteries. Well, right now all lithium batteries are made out of liquid electrolyte. I think the batteries of the future, 10 years down the road, you may get into true solid state batteries, but the market right now and for the foreseeable near future is still liquid electrolyte battery. Whether or not a sealed, battery or with regard to the cells or unsealed is better or worse. That was a topic of debate back when lead acid was king. Nowadays, if you're in lithium, all the cells themselves are sealed. When we talk about a sealed battery with lithium, we're really talking about the battery pack, in which case can humidity and dust get into the battery pack and get onto the cells themselves. Mark, for the price range of this kind of system to already installed to a basic system, I mean, I work in engineering, so that's really where you could email sales@fortresspower.com or get a quote from James. Maybe James.
Our team can really design a system, but the thing is like that's probably the most generic question, because a system really has to be designed, to suit. It's kind of like going to a car dealership and saying, what's the price of a car? Like, what are you looking for, right? What do you actually need? Do you need a workhorse, or are you just trying to get the cheapest car from A to B? Like, you have to really design a system to suit the needs, and the cost to do that is going to vary based on, the system scale and the desired aspects of the system. If you're trying to do full backup, you're just trying to do critical loads, if you're doing a completely off-grid system, there's just a lot of specific criteria that has to get considered when designing a system, and then our team can really gather that information and from you in a very basic phone call and put a quote together probably in like 20 minutes if it's just a general quote, but there's still really pertinent information that has to be gathered to even get close to answering that question.
I think that as far as customers who are budget constrained, and we have a class in our learning portal on this called the Hawaiian Tie-In with a Twist. So a little bit of a catchy name, but I think many installers and end users do not realize that they can, get away with a much smaller inverter than they realize if they're willing to do things like install a backup panel. There are cheap, effective ways to reroute power from a backup panel to your main panel on a breaker by breaker basis. So like if you get a 8 kilowatt or 9 kilowatt inverter, you can still do things like use your, electric tank water heater or 3-ton air conditioner unit on down, but maybe not in an automatic way unless you're buying a smart panel or doing a more, not budget constrained project by definition. But when you're with our eFlex batteries, on an 8 or 9 kilowatt worth of inverter capacity, or two easy solars with 6 kWs and 3 eFlexes, there's really no reason. There's really no single load in a house that you can't power, provided that you are having intelligent balance of system design. And that might mean a small backup panel and then a manual transfer switch to be able to turn the grid off and reroute power from the backup to the main panel on a breaker by breaker basis. So we have a class that goes into a deeper strategy for that. You usually get into the customers who only have $25,000 or $30,000 to spend on their total project scope, wanting whole house backup, and that's not very realistic. So you have to scale back their expectations a little bit.
It definitely depends on what it takes to do a whole home. Like if you have ridiculously large loads, then doing a whole home backup and being able to power those large loads is definitely going to cost something significant. But like you said, if you put in a critical loads panel or you figure out a way to shed those major loads, you can do it on a budget. I mean, you do need some money to do it, but you can do whole home backup and whatnot without spending an absolute fortune. Especially with the scalability too. Like as long as you achieve the minimum number of batteries to start the system, you can always add more batteries after the fact to achieve extended backup time.
All right. Do we have any more questions for Victron since we're here? A little bit over time, but we've enjoyed the Q&A. Well, with that, Rich, James, thank you for coming. We enjoyed your participation and look forward to having you back in the future.
Yeah, thanks for having us. It was a pleasure.
It was.
All right. Thank you.